Hello, everyone. Today we're continuing again with our congruent triangles, and today we're actually going to really talk about congruence and corresponding parts. So we've defined congruence in terms of angles. Congruent angles have the same measure. And we've also defined congruent segments have the same length. But when we're talking about polygons, it gets more complicated because in order to say congruent polygons, they have to have all corresponding parts congruent. So when you name congruent polygons, you always list the corresponding vertices in the same order. So in our example here, we're going to say that ABCD is congruent to quadrilateral ZWXY. So that means our corresponding sides are AB is corresponding to ZW, BC is corresponding with WX, CD is corresponding with XY, and DA is corresponding with YZ. So those are our corresponding segments. Our corresponding angles would be that angle A is corresponding to angle Z. Angle B is corresponding with angle W. Angle C is corresponding with angle X. And angle D is corresponding with angle Y. And what we're doing is we're listing exactly what would be on top of each other if we flipped one of these quadrilaterals on top of the other. So if I could flip ZWXY and place it on top of ABCD, Z would be on A, W on B, X on C, and Y on D. So now to say whether or not triangles are congruent, in order for them to be congruent, all sides and angles are the same. So in congruent polygons, have all corresponding parts are congruent. So, example 1, decide whether the triangles are congruent. So we know B and D are right angles. So if B and D are right angles, that tells us that angle B is congruent to angle D because all right angles are congruent. All I did was read the first given. So that means B and D are congruent because they're right angles. Then I know that AB is congruent to ED. I know that BC, so here I'm going to use 2 tick marks, is congruent to CD. And I know that AC is congruent to CE. So the question is, do I know enough to say whether or not these triangles are congruent? So I have all the sides. I don't have all the angles. Can I say anything else about an angle? So if I look at that triangle, I see that these two angles are vertical angles. So I'm going to say that. So I'm going to say angle BCA is congruent to angle ECD. And that's vertical angles are congruent. So I'm missing an angle. But what do I know about angles of a triangle? Oh, I know they always add up to be 180. So I can say that angle B plus angle BCA plus angle A equals 180. And I actually should say the measure. And I can also say the measure of angle E plus the measure of angle ECD plus the measure of angle D equals 180. And that's because the interior angle sum of a triangle is 180. Well, they both equal 180, so they're equal to each other. So the measure angle B plus the measure of angle BCA plus the measure of angle A is equal to the measure of angle E plus the measure of angle ECD plus the measure of angle D. That's substitution. And then I know that B is equal to D, so I'm going to subtract those from both sides. And I know that BCA is equal to ECD, so I'm going to subtract those from both sides. So subtraction gave me that angle A is congruent to angle E. Subtraction. Which then means these triangles are congruent. So I know that ABC, triangle ABC, and be careful, you need to name them in order. So A goes with E, B goes with D, C, and that's because all sides and angles are congruent. All corresponding sides and angles congruent. Now, the good news is this part right here, we can simplify. That is actually a proof of the theorem. So that theorem is in a triangle, or in two triangles, if two angles, this only applies to angles, are congruent, the third is congruent. If two, actually, I should say corresponding angles are congruent, the third are congruent. Third corresponding are congruent. And so I could have done 4, 5, and 6 there in one step. So let's try number 2. So I want you to pause and I want you to give this a try and then come back. Okay, so hopefully you paused and did this. So what I did first after my givens is I used the GN as perpendicular to CG. So that meant GNC is a right angle and GND is a right angle. And then all right angles are congruent. So I know those two angles are congruent. I then said CGN is congruent to DGN because in a triangle, if two corresponding angles are congruent, the third is congruent. I know GN is congruent to itself because of reflexive. Here we go, way back from chapter 1. And now I know those triangles are congruent because all corresponding sides and angles are congruent. So our last example no, it's not, sorry. We have 2 more examples. So our third example here, they told me that RSV is congruent to TVS. So I'm going to label my congruent parts. So I know that RS is congruent to TV. And I know that based on the fact of how the labels are. RS and TV go together. So that means 2y minus 1 is equal to 24. So I can easily solve for y. So 2y equals 25. Y equals 12.5. Done. That's why it's important to realize how they name them. Then I know that angle T corresponds with angle R. Well, T is X. But if I look at the rest of triangle RSV, triangle RSV, I know two of the other angles. So since T is X, that means R is X. So that means X plus 90 plus 78 equals 180. And that's because right here, RBS is a triangle, and the angles inside a triangle always had to be 180. So that's X plus 168 equals 180. I subtract 168, and X equals 12. Last example. Write a congruent statement for the pair of triangles. So a congruent statement is when we say triangle blah, blah, blah is congruent to triangle blah, blah, blah. So I'm going to start with this one. So I'm going to say D, E, H. Really doesn't matter how I say it. I could have said E, H, D. What matters is that the corresponding parts go with it. So if I'm doing D, E, H, D corresponds with Z. How do I know those correspond? Because they're each marked with one congruent arc. So that's triangle Z. E, or I'm sorry, that's not an E, that's an F. I looked at the label wrong. DFH. So F has two arcs, so F goes with P. And H has none, R has none. So those two go together. And also I should check that DF is labeled with one mark, ZP is labeled with one mark. FH is labeled with two, PR is labeled with two. And DH is 3, and therefore ZR should be 3. So again, I can label it different ways. If I started with F, F goes with P. H goes with R. And D goes with Z. So it's fine if I say triangle DFH is congruent to ZPR, or I could say triangle FHD is congruent to PRZ. And there are lots and lots of ways, as long as the corresponding parts are in the same order. So if you have any questions, please bring them to class tomorrow.